Today's topic is conductometric titrations and its applications of electrochemistry. Conductometric titrations can be defined as follows. The titration in which endpoint determined based on conductivity measurements. The titration in which endpoint determined based on conductivity measurements is called as conductometric titrations. Conductometric titrations are of three types, that is, acid base titrations, precipitation titrations, complexometric titrations. Acid base titrations can be further classified into four types: titration between strong acid and strong base, titration between strong acid and weak base, titration between weak acid and strong base, titration between weak acid and weak base. Examples also shown here. Now let us see conductometric titrations between strong acid and strong base. Here the curve will be like this. Here there are 3 points A, B, C. Here A to B indicates fall in conductance, B to C indicates rise in conductance, B is the endpoint. This is regarding the conductometric titrations between strong acid and weak base. So here also A to B indicates fall in conductance, B to C indicates the conductance remains constant. This is due to suppression of NH4OH by NH4Cl. Here NH4OH is weak base, NH4Cl is salt. B is endpoint. This is conductometric titration between weak acid and strong base. Here let us see the curvature. Just a little bit decrease will be observed. After that, rise in conductance will be observed. A to B indicates rise in conductance. B to C indicates steep rise due to excess of strong base. B is endpoint. This is conductometric titration between weak acid and weak base. Let us see here A to B indicates increase in conductance due to excess of weak acid. After that, B to C conductance is observed remains constant. Here B is endpoint. Advantages of conductometric titrations. It does not require indicators since change in conductance is measured by conductometer. Suitable for colored solutions. Since endpoint is determined by graphical means, accurate results are obtained with minimum error. Used for analysis of turbid suspensions, weak acids, weak bases, mixture of weak and strong acids. Disadvantages of conductometric titrations. Increased level of salts in solution makes the conductivity changes. In such cases, it does not give accurate result. Application of conductometric titrations to redox systems is limited because high concentrations of hydronium ion in the solution tends to mask the changes in conductance. Although there are some limitations, they are very limited, and there are several applications for conductometric titrations. It is used to check water pollution, alkalinity of fresh water, salinity of seawater, deuterium ion concentration in water, food microbiology for tracing microorganisms, tracing antibiotics, estimate ash content in sugar juices, purity of water, solubility of sparingly soluble salts like barium sulfate can be detected. There are 9 important applications. All applications are mentioned here. Thank you. Happy learning.